Once again, welcome back to my YouTube channel, Sriram Devarajan. Today I am going to solve problem from the paper Allied Mathematics 1. I am going to solve some of the problem that was asked in Madras University previous year question paper. The topic is from trigonometry. This problem was asked in 10 mark latest question paper SM3AA. The problem is prove that y equal to 1/2 log sin x minus alpha by sin x plus alpha if cos of x plus iy equal to r into cos alpha plus I sin alpha. This was asked in from the subject code SM3AA for 10 mark question. What is given? You have to prove y equal to 1/2 log sin of x minus alpha by sin of x plus alpha. It is given cos of x plus iy is nothing but r times cos alpha plus I sin alpha. Solution: given cos of x plus iy equal to r into cos alpha plus I sin alpha. It can be written as r into cos alpha plus IR sin alpha. LHS is of the form cos of a plus b. We know from +1 mathematics trigonometry chapter cos of a plus b cos a cos b minus sin a sin b. Here a is nothing but x, b is nothing but iy. Therefore, LHS becomes cos x cos iy minus sin x sin iy, which is equal to r cos alpha plus I into r sin alpha. We know the value for cos iy. It can be written as cos of hy, here cos x. Similarly, sin iy answer is I sin hy sin x, which is equal to r into cos alpha plus I r sin alpha. Now, equate both sides, real and imaginary parts. What is real part and imaginary part? If the complex number is of the form a plus ib, this a is nothing but real part, this b nothing but imaginary part. Here cos x cos hy real part, LHS, RHS r cos alpha real part. Sin hy sin x LHS imaginary part, r sin alpha RHS imaginary part. Equating real part and imaginary part on both sides. What is LHS? Real part cos x cos hy. Real part RHS or cos alpha. Imaginary part minus sin x sin hy here or sin alpha. This is equation 1. This is equation 2. Divide 2 by 1. What will get? Numerator minus sin x sin hy, denominator cos x cos hy or sin alpha by or cos alpha. R cancel. Sin by cos from trigonometry we can write it as minus tan x. Sin hy cos hy can be written as tan hy. Sin alpha by cos alpha can be written as tan alpha. This can be written as tan hy equal to minus of tan alpha by tan x. Again it can be written as y equal to tan h inverse of minus tan alpha by tan x. From inverse hyperbolic function for tan, we have one result. Already that result was proved in my video in my YouTube channel. That result is y equal to half log 1 plus x by 1 minus x. This y is nothing but tan h inverse of x. See, for tan h inverse of x, the answer is half log 1 plus x by 1 minus x. Here, in place of x, we have minus tan alpha by tan x. This part can be written as capital X. Therefore, the formula becomes half log 1 plus x by 1 minus x. This is equivalent to half log. Here, formula is plus x, but we are getting answer in terms of minus. Therefore, it becomes 1 minus tan alpha by tan x divided by 1 plus tan alpha by tan x. This is equivalent to half log cross multiplying tan x minus tan alpha divided by tan x divided by tan x plus tan alpha divided by tan x. Tan x cancel. What we are getting the final answer of log tan x minus tan alpha divided by tan x plus tan alpha. Again, we can write tan x by sin x by cos x, tan alpha by sin alpha by cos alpha to get the final answer. This is equivalent to 1 by 2 log tan x means sin x by cos x, tan alpha means sin alpha by cos alpha divided by sin x by cos x plus sin alpha by cos alpha. Cross multiplying. The answer is 1 by 2 log sin x cos alpha minus sin alpha cos x divided by cos x cos alpha again divided by sin x cos alpha plus sin alpha cos x divided by cos x cos alpha. Cos x cos alpha will get cancelled. See the numerator. It is of the form sin a cos b minus cos a sin b. Denominator sin a cos b plus cos a sin b. Therefore, half log sin x cos alpha minus sin alpha cos x can be written as sin of x minus alpha, numerator, denominator sin of x plus alpha. This is the final answer for this problem. Repeated Madras University question. Thank you. You subscribe my channel, like my channel, share my channel to your friends. Thank you.